All right, welcome to the last module. I'm going a little fast here. The last lecture for module 1. We are going to wrap up our overview of the basic, pretty much, concepts for object-oriented programming in Java. Okay, so last lecture we finished with the slideshow had example of the date class and the random class. I want to stress out I didn't go over those in a class. It was like 6 slides, I think, but please review them in the reading assignment. That should be straightforward, okay? This is generally not the kind of stuff that causes problem to students, but I want to stress out that yes, you should take a look at the examples in the reading assignment. I have a question, Joseph? Okay, I had a hand raised, but apparently either no question or your mic is not working. Use the chat window if you have a technical problem, okay? Other than this, I'm going to jump in the first slide. So we are going to continue where we left off. We have introduced already the concept of visibility modifier. As is usual, in this course, I introduced the concept a little bit informally with examples, and now we're going to go over the formal definition. So last time we started hiding things, okay? And this is going to be a theme for this course. So we started hiding things, okay? More specifically, we hid some attributes. And we were like making sure that, for example, a class had all of its attributes hidden, and we use the keyword private to do so. And then we would look at the accessors and the mutators, the method that allow us to read and write pretty much the value of attributes. And we would make sure that, for example, none of them allowed us to, in one way or the other, modify the attributes. And then we would say this class is immutable, and that would create immutable objects, and immutable objects had a guarantee with them, which said pretty much once you create that object and you are done running the constructor on it, the value of the attributes are never going to change. So this is the last concept that we covered last time, okay? And as I said, we used already that private keyword. There's another keyword on this slide that we have been using quite often, the public one. Okay, so actually public and private are the only two keywords, Java keywords, on this slide, and we've been using them both. So what we're going to do now is we're going to define them exactly, and we're going to take a look at, you know, when you should be using one or the other. And starting from today on, we are going to be a little bit more formal, a little bit more rigorous in our usage of the public or private keyword, okay? Until now, because I didn't use the concept of visibility modifier, sometimes I use one, sometimes I use the other, etc. But now we're going to be really formal about that, okay? So let's see. So the idea of visibility modifier is that in front of any declaration in Java, so declaration of an attribute, for example, inside of a class, or declaration even of a method inside of a class, okay? So we're talking about declaration of class members, attributes or method. In front of each of those declarations, you may have three scenarios. One, you put the public keyword. Two, you put the private keyword. Three, you do not put either public or private, okay? So default, as is indicated on this slide, default is not actually a visibility modifier, okay? Default is when you don't have any public or private keyword at the beginning of the declaration of an attribute or at the beginning of the declaration of a method, then it's considered visibility, default visibility, okay? So what does that mean, default visibility, public visibility, or private visibility? Okay. So this has to do with who you are going to allow to see your attribute or method and use it. Okay. So let's start with private, the one that we used last time. Okay? So when you say that something is private, That means that it's only accessible, it's only visible and usable inside the class where it is declared, okay? And this is consistent with what we've seen last time. Last time I wanted to lock down some attributes, so I would mark them private. And then suddenly the code inside the class itself, where those attributes are declared, well, nothing really changed. I was still able to, to access those attributes, to use them in my method. But when I created an object of that class, then suddenly that attribute was no longer accessible. Public is the opposite. So private locks down an attribute or a method so that you can use it only in the class where it's declared. And public means no matter what, you're going to be able to use it. So no matter what means you can use it from the code of the class itself. You can use it when you create an object of that class inside the main or inside a method in another class. Wherever you are going to be able to access those attributes and methods that have been marked. And then default is, of course, an in-between. Okay, private and public are absolute lockdown or everything is open door policy. Okay, so these are the two extremes of visibility. The default visibility modifier, when you don't specify private or public, means this attribute or this method is visible to other classes, but they have to be in the same package. So I already mentioned that the concept of package is not something that we're going to explore a lot in this class, okay, but I'm going to mention it during this lecture. So a package is pretty much a group of classes that are really meant to work together, okay? So those three levels allow you to pretty much say everything is protected, everything is private, sorry, everything is public, or I'm going to be public only to a few classes that happen to be in the same package than me. All right. Let me catch up with the chat window because I heard there were some things scrolling there. What topics should we review for GQ01? So GQ01 is the entire module 1. Okay, so the entire reading assignment for module 1, Jonathan, this is what is at the menu for GQ01. Will we go into protected fields and method? Yes, but not now. Okay, the protected keyword, there is a fourth visibility modifier. Okay, the keyword is protected, as Mark pointed out. But this is relevant only when you use a technique called inheritance. So we are going to introduce inheritance in module 3. One of the things that we will do is we will revisit visibility modifier, and we'll have a little bit more to say about the protected keyword at that point. Okay. John is asking, will it be part of IE1? This, what we covered today, is part of IE1. Absolutely. Okay, we are finishing module 1. This will be also part of IE1. All right, so going back to UML notation, we just introduced something new, okay? Well, it's not exactly new because we have been using public methods since the beginning. And last time we used private attributes. So now we are saying, okay, you can have public or private methods and attributes. So you can have like default visibility ones if you don't specify anything. So we need to update our UML notation. We are not going to really change it because I've been using that system since the beginning, but we are going to comment on why sometimes there was a minus symbol in front of a name of attribute or method, and why sometimes you found a plus. So the fact that all the plus are on methods and all the minuses are actually on attributes, don't let that fool you, okay? This is not a rule. I can have a plus in front of an attribute, that means the attribute is public. If I have a minus in front of an attribute, that means the UML diagram is telling me that I should declare that attribute as private. And the same rule goes for method. If I have a plus, then it's public. If I have a minus, then it's private. For now, and this is something we're going to rediscuss in a little while, okay, but for now, the constructors, you are going to notice that I tend to make them public, always, okay? So it's not a rule. I could have a private constructor, or I could have a constructor that doesn't have the public or private keyword in front of it, so it would assume the default visibility. But these are kind of a bit advanced techniques, okay? They don't really come in handy when you're like just getting started learning about object-oriented programming. So as you get started in object-oriented programming, most of the time, the vast majority of your time, your constructor are going to be public, simply because the constructor is what you use to construct objects of that class. So if it was hidden away, what could happen is that maybe you will not be able at all to construct object of that class. Why would that be a good idea? Good question, but we're going to talk that in a little bit because, like I said, it's a little bit of an advanced concept, okay? So we need to cover a little bit more ground before we start doing stuff that is that weird with our classes, okay? But here, for example, we have a variant of our simple circle class, okay? It has a radius. The radius is private. It has another attribute that we'll talk about a little bit later, which is called number of objects. This one is private as well. So the UML diagram is telling me all of my attributes are private. You're going to see that this is something that we're going to do very often in this class, okay? We are going to write classes, and in order for us to guarantee that somebody is not going to assign a bad value in one of our attributes, well, our first level of protection will be to almost always say all my attributes are private, okay? So that way, nobody can modify them. And then, if I want to allow somebody, for example, to read the value of the attribute radius, I'm going to write a getter method for that attribute. So when I say I want you to write a getter method or a get method for the attribute radius, that means exactly that, okay? That means that we have an attribute radius first. We most likely made it private, otherwise we would not need a getter, right? And now I want to allow people to get the value of that attribute, so we are going to write a get radius method. That get radius method, please note, it's public, okay? So the attribute itself is private, but I have a get radius method that's public that people can use to actually access the value attribute. And if I wanted, I could also ask you, please write a set radius method, okay? Make it public. And if that's the case, then you would have access to both the radius attribute to write its value or to read its value, assuming that those two methods are public, okay? But to do so, you would have to go through our method, the method that we are going to write in this class. Question from Mark: would you be able to use the radius method on the now? Yes, absolutely. So if you write a set radius method and it's also public, okay, now everybody who creates an object of your class, they cannot change directly the value of radius, but they can get the value of radius using our method get radius. They can change the value of radius using the method set radius. What's the advantage of that? Well, if I make radius public, it's everything goes, read and write. Anybody who creates an object of my class can read the value from the attribute and assign a value. There's no finer control, okay? When I hide my radius, I can decide, for example, that people can only get its value. And so I make a public method get radius, right? And now that's it. Nobody can change the value. Or I can decide that people can set the value, but not read it. That sounds a little weird, right? But let's say that it's another class, another problem, and that makes sense in that context. Yeah, I have the liberty to actually make an attribute that can only be set every time you want to change it, but that can never be read. Okay, think about like a game, and this is a secret number that you have to guess, like one of the guess the number game that we wrote a little while ago in COP2513, right? Well, this would be an example here where you don't want your attribute to be readable. And then you can make an attribute private and then have both a set and get version methods on that attribute and make them both public, in which case you can set and get. And again, the main advantage is the set method. You can put a bunch of if statement in that set method that's never going to let anyone change the value of that attribute to anything that you didn't accept, that you didn't validate, okay? If you say, for example, the radius has to be 0 or above, then you set radius method, you may actually test. Are you trying to set this radius to a negative value? If so, then I'm not going to change it, okay? Sorry, too bad, okay? All right, so there are advantages in terms of making your code more resilient to abuses and misuses, okay? So this is pretty much the main idea here of that visibility. We want to be able to hide things and protect them from other programmers' mistakes. All right, so let's take a look at a code example. So we're going to still use the running example of the simple circle, okay? This time, instead of showing you first the code of the simple circle class and then the code that uses it, I'm going to do it other way around. So here's a class named simple circle. So it contains only a main, and inside that main, I'm going to just play with my class simple circle, create objects, do things with those objects, just to make sure it's working. Question in the chat from Elijah. So you can use private methods as like a stopgap from possible mistakes other programmer may run into? Yes, that's the idea. Okay, but it's not private methods that are going to do that. Private method means, okay, that method, only the person who is writing the code of this class needs it. That's what private means. That attribute, that private attribute, it's only usable from within the code of the class. When you say then you are going to have setters and getters, you allow other people to access those fields. Let me take a live example here real quick, because I have the feeling this concept is not so clear right now. So let me create a new file, okay? And please throw your question as we go over this example, okay? I want to really like completely demystify the visibility modifier bit here. So public class my data, okay? So this class is going to hold some data, as the name implies, okay? So I'm going to say, all right, so we're going to start by saying public data1, okay? And then I'm going to create a public constructor. So from now on, because we don't use a lot of packages, most of the classes and methods are going to be either public or private, okay, in the exercise that we're going to look at, and the upcoming exam IE1, for example, okay? But if I ever ask you to do, I want a data one with a default visibility, then this is default visibility, okay? Like you define, and I forgot the data type here. So if you define int data one, it's default visibility. If you say public int data1, then it is public visibility. And if you say private, it's private visibility. So let's go back to the first ID here. Public int data1. I'm going to write a constructor. You give me a value, okay? And I assign this value to data1. Okay, so this is the kind of stuff that we have been writing so far, except that now I'm putting a focus and emphasis on, hey, please look here, okay? Look at what's happening here with the public keyword. All right, so if I save this, if it's like the correct data, there we go, and I want to use it from another class. So I have like a class here that just has a main. So if I want to be able to say my data d1 equal new my data, and I'm going to say this is the value 5 that I want inside of there, okay? If I want to be able to do this, this is not a problem, okay? I can create objects of the class my data. I can call the constructor that takes one parameter. There we go. If I run it, it doesn't display anything on the screen yet, but it's working. Okay. All right. So now let's talk about this public modifier for the attribute, and then I'm going to write a method so that we see also how it works with method. So the fact that data1 is public means that I can write things like data1 equal 42. So I can access with the dot notation the attribute data1 inside the object referred to by the variable d1, and I can even do some things like system.out of println, and I can do d1 dot data1. Okay. So the bottom line here is that I have full access to this attribute data1 because I marked it as public. So full access means full access with a dot notation when I create an object of that class elsewhere. Elsewhere means another class. That can be inside the main method, that can be inside a method of another class. It's not inside the myData class. Does that make sense? So let me run this, and then I'm going to jump back in the chat. So if I run this, blah, blah, blah. So it displays 42, which means that I was able to assign a value that overrode the 5 and then display it. So wait, so what does V represent in the other code? Okay, so let's go there and let me clarify. So what do we have in the other code? The other code we have, sorry, I didn't click correctly. There we go. In the other code we have one thing, an attribute. So every object of class myData contains an attribute named data1, variable, if you will. And then we have a constructor. The constructor says, give me a parameter v, and I assign it to my attribute. So this is what happens here, right here. When I create my data, okay, I pass as parameter v to the constructor the value 5. But then I overwrite it immediately. Let me show you with the debugger, step by step, what happens, okay? There we go. I'm starting my program. I'm about to create the object. All right. So right now I have nothing in memory. Let me skip over this. So now the variable d1 refers to an object of class myData, object number 214 in memory. Inside that object, I have data1 equal 5. So you see how the 5 that I passed here, okay, was passed to the constructor in myData as v, and v was assigned to the attribute of that object. That's why that object has data1 equal 5. All right. And then what I did is I modified d1.data1 equal 42. There we go. And then I displayed whatever was in d1.data1. 42 goes on the screen here. Does that make more sense? So other question. For the myData part, is it using the class name or the method name for the myData part? So I'm using the class name here. Okay, I haven't called any method yet. Okay, this is a class name. This is a class name. But watch out, Mark. Okay, I think I understand where your question comes from. Here, this is definitely the class name. Here, it's also the class name. But remember, the name of your constructor is also the class name. Okay, so the class name is used to both give me the data type of D1 and allow me to call the constructor so that my object, once it's in memory, can be properly initialized. All right. Question from Seth. So for myData D1 equal new myData, is it basically like assigning D1 as an int? Confused on that. No, it's not assigning as an int. Okay. Remember, above line equal 4 steps. Okay, I'm going to put that as comment so that when I upload the file, you guys will have a reminder. Okay, so what does that mean? That means that when you execute a line like that, the first thing that happens is you declare D1. So D1 is a local variable, okay, that exists in the main. And then you create an object of class myData in memory, new. That's what the new keyword does. Then once the object exists in memory, you call the constructor, one of the constructor on that object, okay? And then once the constructor is done initializing the object, you put the reference to that object inside the variable D1. So these are the 4 steps that we covered last lecture, right? When we do, anytime we do something like that, you know, a reference data type, name of the variable equal new, the name of the data type, parentheses, and potentially 1 or more, 0 or more argument, that every time those 4 steps get repeated, okay? So what value does 5 have? So 5 is a value. So 5 doesn't have any value in and by itself, okay? But 5 is a value that I pass to actually the constructor here, okay? So that v parameter, okay, if I go back here, I run again the debugger, but this time instead of skipping over the construction, I go in detail, right? You're going to see in a minute. There we go. I'm here. I'm about to construct my object. I click on the bent arrow. Okay. I jump into it. There we go. You see exactly what's happening now. Okay. So what's happening is that the constructor for the class myData was called. Right now, inside that object, data1 is 0, because by default, it's going to be 0 here. And I receive a value from the main that is 5. This is, if I go back to the main, this is a value that I passed as argument right here. All right. So I receive that value as a parameter v, and then I'm going to assign whatever is in v inside data1. So data1 change here and take on the value of v. There we go. There we go. Okay. And then when I'm done, I return. And now I finish creating my object. So the variable d1 refers to an object of class myData. This is what it tells you here. And inside that object, the attribute data1 is equal to 5. Does that make sense? Before we go any further, because I realized that there was a need for some review on what we discussed last time about how objects are constructed. So before we go any further, let's take a look at this code, this example that doesn't have much yet about visibility modifier, but let's use it to clarify everything that needs to be clarified. So a few of you have questions, and I mentioned, in passing, so does that make more sense now? And then I went to the next question, just to not leave like a blank pretty much in the lecture. But yes, if it doesn't make sense, please let me know in the chat, okay? If I don't hear back from you, I'm assuming it made sense, but I'm going to go to the next question so that we can save time. But please, if it doesn't make sense, say something. So, okay, it made sense for you, awesome. All right, so yes, I can definitely run this code. So I'm going to stop it, and I'm going to run it again. And there we go. It displays 42 on the screen. Okay. Create an object of type myData. It has 5 inside of it when I'm done creating the object. Then I change that value from 5 to 42, and then I display what the value is inside that attribute. Okay. So, and all of this is before we actually start messing around with public and private, okay? So this is really important that we take a minute here, and if you have any question about this code, throw them in the chat now, okay? So does it run 5 first? Yeah, it doesn't run 5 first, but it takes the value 5 first, and then that value is changed to 42. So that also addresses the next question in the chat, which is, so 42 overrides the value 5? Absolutely, you got it, okay? We start with 5 in the object here. Let me show you, actually. You should not believe me. You should ask for code that shows the stuff, right? So let me show you real quick. There we go, system.out, what's in the attribute, okay? And this is going to take care of your question, Joseph, too, which is, so if you didn't assign, would you display 5? Well, you guys are going to see that right away. Let me run it. All right. So it displays 5 first, because after creating the object, okay, I ask the object to be created with a 5. And then I change the value of the attribute, display it again, and now I see the 42. So the reason why we write the constructor is so we don't have to keep declaring the object to assign data a new value. No, the reason you write the constructor is because when you create an object, you want a specific value inside of it. Let me illustrate that, Jonathan. What if I add another constructor here? Okay, public myData. This constructor doesn't take any parameter, okay? And it says data1 equal, and we're going to put there a default value that supposedly makes sense in the context of our application. For example, the default value for the data1 field should be 999. Why? Okay, so now I have a situation where if I am happy with the default value that the programmer of the myData class decided to use, then I can create an object like this with that parameter. And if I run this, you're going to see that it's taking a lot of time to run. Huh? Okay, so you're going to see that the object is created, and the default constructor puts a 999 inside of it. Okay, I display this, and then I change the value to 42, and then I display that again. All right, but now if I'm not happy with that default value that the code of the class myData offers me, then I can say, wait a minute, I don't want that default value. I don't want 999. I want just 9. Okay, and I typed in the wrong pane. So let me go back here. I just want 9. Okay, if I want just 9, save, build, run. So now I'm calling the over constructor, the one that takes a parameter. That over constructor puts a 9 inside my attribute, and you can see that I can display it here. So it displays 9, and then I change that value if I want, and I can get the new value to be displayed. Okay? All right. So most of that was, review of the stuff that we covered before, but I want to draw your attention that I marked my my data1 attribute public. Okay, it's because it's public that I was able to use the dot notation here inside an over class to access the attribute, either to read it or like here on line 10 to change its value. Okay, so public means over classes can use the dot notation. Now I'm going to mark it private. You're going to see immediately the difference. I'm going to go back here. I'm going to compile both files. So compile this. So my data compiles just fine. And then when I try to compile the class with the main, let's take a look. Well, the compiler is not exactly happy. Okay, the compiler is telling me data1 has private access in my data. So in the class my data, I marked the attribute data1 as private access. So the compiler denies me the use of the dot notation here, starting the variable d1, to access data1 inside of it, because it's private. It denies me also access here. That's the second error. And then it denies me access here. Please note that, and this is really important, the compiler didn't have any problem with me accessing data1 here and here inside the class myData. Okay, so private means that this data1 attribute is still perfectly fine to use inside the code of class myData. So private just means when another class tries to access it, inside an object of class myData, then we lock them out. Okay, so the concept of privacy is when you are in the code of a class, of the same class where the attribute is defined, there's no privacy. Everything is full access. You are writing the code of that class. It's normal that the code can access all the attributes. So this is only for over classes. Like for example here, my M1L5 live class that has a main. Well, yeah, this one doesn't have access anymore. So that allows me to prevent this kind of stuff. Okay, setting values that I don't want people to set in my attribute. So it recognizes that it exists, but it's unable to be used. Yes, it does exist. Okay, it exists. It's usable again inside the class where it's declared. So all that code use it. And let me confirm to you that indeed it really exists. Actually, I cannot do that because it's not compiling. But as soon as I get it to compile, I can show you that when the object is created, like for example, if I remove this. I'm going to remove all the code that is an issue right now, okay? But I can confirm to you that if I save this, so I'm just creating the object, and I run it, there we go. And I should not run it, I should run it with the debugger, actually, that would be better, right? So run it with the debugger, there we go. When I execute this line 7, there we go. It created an object, the variable d1 refers to that object. Inside of that object, there is a data1 attribute. It exists, Marcus, okay? Confirming that to you. And it was assigned the value 9 because this is what I said I wanted as default value. So we would need to create a constructor setter to change that value that is private. Yes. So the constructor, we didn't change anything for the constructor, okay? Constructor is still public. And like I told you, most of the time in this class, my constructors are going to be public. Okay, you can assume this is a rule there. But yes, I would have to provide a setter and a getter to allow read and write access. So let's start with the getter. Public get data. Okay, and I'm going to drop the data1 shtick because we have only one attribute so far. So I really don't need to call it data1. I'm going to just call it data, okay? So data equal v, data equal 999, get data, returns data, okay? And I'm going to update my main as well. So every time I was using data1 here, I'm going to use data. Okay, so now what I'm trying to do is I'm trying to allow myself to do this, to read the attribute inside the object. But here's the deal. My attribute is still private, so if I try to do it like this, okay, save, compile, the compiler should still be yelling at me. So let me first stop the debugger and compile this. Yep, it's still yelling at me, okay? So it's telling me, well, first it's telling me that I probably didn't declare something correctly. Hold on. My data, line 13, I have a typo somewhere. Yes, public get data. What is the return type? It has to be an int. I forgot that. So get data is going to be a lot better. So let me compile this file first, make sure I didn't do anything stupid elsewhere. There we go. Now I'm going back to the main. I'm trying to compile it. And compiler is going to get because d1.data is still not allowed. So instead of doing d1.data, I need to call the public accessor, d1.getData. Okay, it achieves the same job, right? It gets the same job done. It's going to go inside the object referred to by a variable d1, and it's going to this time run this public method, so it can access it because the method is public, and that the public method will return to me the value of the attribute. But I was not allowed to go and fetch that value directly from the attribute. So now if I build and run, it should work. Awesome, it's working. So I saw or I heard more somebody raise their hand. Joel, you have a question? Okay, so we're going to move on. When you click the hand raise icon, okay, make sure you guys have a question so that you can type it in the chat window, you can text the microphone. Anyway, so moving on. So now this is working, right? I can get access to the value of the attribute data. That's super. So now let me go here and change that public, not that one, this public. Public int get data, okay, let's change it to private. This is kind of weird, okay? So I lock down my attribute. My attribute is still private up here. And now I wrote a get method for that attribute, a getter, but it's also marked private. Okay, so let's compile this. And we're going to see what that does. When I try to build this, wow, it's still not happy. Well, of course it's not happy. I'm trying to ask something that's private, okay? Hold on. So Edgar had a question about declaring an array, but I'm not declaring an array. Okay. My data D1, I mean. So yeah, I'm not declaring an array here. These are parentheses, not square bracket. So this is me calling my constructor. Okay. So new my data, open parentheses, 9 parentheses. Okay. So the same thing happened with an attribute or a method. If it's private, when you try to use it from another class, right, it's not going to let you. So here I showed you like how I could lock down one attribute and how I could lock down one of my methods. But of course, in this example, there's very little advantage for me to have a getter method and then make it private. It's kind of a weird move, okay? Under certain circumstances, that could make sense, but really, really not here. So what I'm going to do now, I'm going to add another method. I'm going to make it public too. It's a void method, set data, that takes a parameter v for value. And that method is going to do something like, for example, if v is greater or equal to 0, then I'm going to allow you to change the data field data to the value v. Okay, the setter method, it's a mutator. So this is called a getter method, a get method, also known as accessor. This is a setter, a set method, a mutator for the attribute data. Both methods are designed to work with attribute data, okay, to read or write the value of it. So I'm going to save that. So now I have two methods, a get and a set method, all right. I'm going to compile this file, move back to the main, and I'm going to use the set method here. So I'm going to say, instead of D1 data, which I'm not allowed to use, right, I'm going to do set data. And now I need to pass as parameter the value that I want to set. So here we go, set data 42. Okay. And similarly, I'm going to cut and paste this. So we're going to be back to our original example, but this time we rewrote the code so that we could accommodate the fact that the attribute was actually private. So let's try to build that. Try to run it. There we go. It's working like it used to, okay? But it's working like it used to with now an attribute that's private, which means that if I was being silly and I was trying to set, for example, a value to minus 42 instead, okay? Since I decided that data would accept only positive values, my setter method, my set data method, is going to intercept this, and it's going to make it not change the value. Let me build. We run. There we go. There was a 9 to start off with. Now I try to set to minus 42. Well, that didn't work. Okay. And so the value that was there originally is still there originally. Let me catch up with the chat window. So Jonathan, do we need to bother with the word public if we know it's going to be public? Yes, because public and not saying anything are two different visibility modifier. So in other terms, this here, for example, let's take this method. This is different from that, okay? And the difference shows when you are using packages. Since we are not using packages right now, both of our files are in the same folder, which means both of the class are in the same folder. This is why we were able to get away with not putting public sometime everywhere, because we were using, a very simple scenario where everything is in the same folder. So when everything is in the same folder, if you don't put anything as far as visibility modifier, it's kind of behaving like public. But if we were moving our class in a different folder and using the concept of package, then yeah, that would make a difference. All right. Question: why isn't 999 printing? Because 999 is a default value assigned by the constructor, and the constructor I've been running is this one. Okay. Try to run this code when I post it on Canvas, run it with a debugger. We've done it a few times already, so I'm not going to redo it again, but when you run it with the debugger, you are going to see exactly which of the two you are triggering, okay? And just to give you like a quick answer, if I was doing this, right, I remove the 9, then, there we go, let's try it real quick, okay? If I remove the 9 here, I would trigger the default constructor, which would put 999 inside the object. So when I display here, it says 999, and then I try to change it to minus 42. Well, that doesn't work because of my if statement. The if statement is standing guard, okay, and preventing me from putting negative values. And then when I display again, it shows still the same value. And if I put 42 here, let's play with this code a little bit, okay? So now this is an acceptable value for the set data method. So I start with 999, then I set it to 42, so the value change, okay? So I'm kind of browsing through the chat here. So it sounds like you guys already converged toward this answer. Nadine had a question: why did you use public void for set data? Because I want this method to be public, okay? So I want it to be usable on object of this class inside other method, and a void because it doesn't return anything. That's why. So how do you feel? How does everybody feel about this example? Did that help clarify a little bit both the stuff from last time and those visibility modifier? So we are going to mostly use public and private, okay? The vast majority of the time. Cool. Okay, I'm happy to read that it helped a little bit. Okay, so don't hesitate when you guys are getting confused about like me piling up new concept. okay, don't hesitate to give me a shout like that in the chat. We can jump into JGraph, live code something and try to tie things up together with the previous stuff, the new stuff together, and that generally makes for a smoother learning experience. Okay. So we've done things that were comparable to what we have in this example. So now that we go back to the slide and we look at this textbook example, that's going to sound like probably a lot easier, a lot more familiar, okay? But again, jump in the chat window if not. So what are we doing here? So we have a test simple circle class with a main method. Create a new object of class simple circle. So the class simple circle, we have been using it as a running example for the past few lectures, okay? So it's just a class that contains a radius, and you can compute the area, you can get the radius value, you can get the area value that you compute on the fly. So these are the methods that are available. So I create an object, I call a few methods on it, then I say I want to change the radius of that object, and I want to change it to the current value of the radius multiplied by 1.1, and then I display again the radius and the area. Okay, so a side effect, like a side remark, it's nice to have get and set methods everywhere. Okay, it's a pain in the rear to write them, I'll give you that. Okay, but it's nice because now get, radius, and area, I can call those to get respectively the value of the radius of the area, but I don't even care which one is an attribute. I could have a class where, I don't know, like the radius is an attribute, and maybe the area is also an attribute, or like the area is computed on the fly based on the radius, or maybe a little more weird, I could have a class where I store in an attribute the area, but then every time you ask me what is the radius, I compute the radius from the area. So yeah, I could have all sorts of possible implementation of this mess. Okay, the beauty of using get radius, get area is that I don't have to worry about which one is an attribute. I access everything with methods, whether this is attribute value or changing the value of an attribute, or whether this is computing, a value on the fly. Like if you remember the get area method from last year, it takes pretty much a radius, multiplies it by itself, multiplies it by pi. So there are things that are computed on the fly. There are things that are just attribute. But from my perspective, the perspective of the programmer working on the main method of the class test simple circle, I even don't care. I just don't care. I just call methods and I get results, okay? So that allows you to better abstraction. By better abstraction, it means that I'm not imposing on whoever is a programmer writing the simple circle class. They can do whatever they want with their attribute. They just hide them. They say they are private. I'm never going to put my nose into that. And we both can work independently, and work together efficiently, but still have freedom of doing what we want in our respective code without impacting the rest of the team. So here's the code for simple circle, private radius. So that's it. We're using the private keyword. Our constructor is public. Okay, that didn't change. We have another constructor that's also public. So like I said, our constructors are going to be public for the time being. Okay. Then I have a get radius. I make it public so that people can get the value of the radius. Set radius, I make it public so that they can change the value of the radius. And then I have a public method get area. So get area, the name, it sounds like a getter method, right? Like for an attribute area, but there's no attribute area. So this is just a method that's going to compute on the fly, what is the area of that circle. So not all methods that start with get are getter methods. Not all methods that start with set in their name are setters method, but the convention generally is that if I have an attribute named blah, okay, if I ask you to write a setter for the attribute blah, it is going to be set blah. And if I ask you to write a getter for the attribute blah, that's going to be get blah. What is a question mark in the set method? Okay, so ignore this for now, okay, if this is like a new notation, but go back to the chapter, I don't remember by what number, the chapter on conditional statement, if statements, okay? This is called a ternary conditional operator. If you hang around at the end of the class, I will explain that to you, okay? It's just a syntax to make a very compact if statement. But if you don't remember it, when you write code yourself, you don't have to use that notation. If you're not familiar with it, you don't remember it, this is not a big deal. But I would like for you to be able to read it when you encounter it. So hang around at the end of the class and we'll talk, okay? Could you explain the notation for the set radius method? Same question. I'm going to skip this, okay, because it's kind of like a detail at this point. And if you guys didn't discover it in COP2512, let's not go back to that right now. You don't need it to write code that works. You can write an if statement if you prefer here. But for the interest of saving a little bit of time, yes, please hang around at the end of the class and I'll go in more detail, okay? Edouard, did you have a question?
Yeah, it was kind of related to that set radius thing. I was wondering, could you rewrite that set radius to just like for it looks like it's like radius minus parentheses new radius greater than. Can you just rewrite that to like radius equals new radius?
So let's do that at the end of the class, okay? Because this is really COP2512 material, and if it was stuff that I would ask you to write in your code, I would cover it now. But since I'm not going to ask you to use that notation, just read it. Let's cover it at the end of the class, okay? If we have a little bit of time, because I need to make sure we cover visibility and the desk.
Well, I recognize the question mark and the new race. That I recognize as the old if.
Yeah, it's a weird if statement. You can identify it like that for now, you know. It's a weird syntax for a if statement. So why do we use the private data fields methods? So it's that duality of we want to share code, but we want to be paranoid about it, okay? We want to pretty much protect our code from other programmers that might misuse it. And one of the questions that I got, I think it was last year or 2 years ago, one of the students asked, but if we want our fields to be private, isn't that weird that we provide then a public get and set method on that field? Okay, you're like allowing access after locking it down. Yes, that's true, but I can fully control the access, okay? Meaning that in my code, I can decide my getter is going to be, for example, public, or my getter is private, the setter is public, or maybe the setter is private, my getter is public. So I have a finer way of controlling access. That's the first thing. And the second thing is when you try to change a value, I can very well, okay, have some extra code here to prevent you from messing around with my attribute in ways that I don't want to allow. Okay, so yes, the attribute is private, but we don't have to make the setter public. We don't have to make the getter public. If we make both of them private, then everything is private. The attribute is still completely out of reach, right? But whatever you allow access to, you have perfect control of how people are going to use it. That's the point. If new radius is greater or equal to 0, print new radius else 0. Yeah, that's a translation of that ternary conditional operator. Thank you, Joseph, for posting that. Yes, other programmer, of course, every programmer but oneself is a noob, right? And until you write some code, and then 8 months, 6 months after, you work with your own code, and then you realize that you don't remember how to use properly your code. And if you didn't write it so that it's robust, then you're your own self noob at that point, okay? So you have to be really careful with that. It's not only just over programmer. I like to joke about over programmers are breaking my code, but generally, yeah, what the over programming is also what I do. All right, so let's sum up here what's going on with private, public, and we're going to talk about the default one, even though we're not going to use it much, okay? But remember that if it's not private or public, then it's default visibility. So this is the only time in the class where I'm going to talk a little bit about package. There is a way in Java to say at the beginning of your Java file, this Java file belongs to this package, and you put the name of the package, okay? So let's say that we have 3 Java files, 3 classes, okay? Public class C1, C2, and C3. So we are going to say that those 2 classes are in the same folder, in the same package, named P1. And then that class is elsewhere in a package, in a folder named P2, okay? I'm a little bit oversimplifying here by saying package equal folder, okay? But I'm not that far from the truth, and it's good enough for the purpose of this course here. So let's see what we have. In C1, we have 3 attributes. Conveniently, one is public, one is private, and one, the int y, I didn't specify if it was public or private. So that means it has default visibility, which pretty much it's public inside the package and it's private outside the package. That's what default visibility is, really. So similarly, I have 3 methods, M1, M2, M3, and one is public, one is private, and the middle one is default visibility. So this is my class C1. So now let's see how we can access those attributes and methods from within the same package and within another package. So class C2 is in the same package than C1, remember? Class C3 is in a different package. So let's take a look at C2 to start off with. So class C2, I try to create an object of class C1, no problem. That's going to work also, by the way, anywhere, okay? Because my constructor is public, all right? So I don't have a problem creating objects from anywhere. My class is public, my constructor is public, everything is shiny. Now, once I have a reference to a new object of class C1, if I try to access O.x here, it works. If I try to access O.x here, it works. Same thing if I try to call the method O.m1 or O.m1, okay? So accessing the attribute x and the method m1 works from everywhere because they are public. All right, so that's what public means. All right, next example. What about O.y? So I can access O.y from within the class C2. I cannot access O.y from class C3. Similarly, I can call method, which one is it going to be? O.m2 here, and I cannot call method O.m2 here, okay? So what's happening with y and m2? Well, y and m2 have been declared without the keyword public or private. So we call that default visibility, okay? So default visibility means that they are public for other class in the same package. That's why this one is able to access them. But they are private for classes in a different package. This is package P1, this is package P2. So, yep, we cannot access those attributes and method. And then the last example is, what about if I have a private method and a private attribute? So from the same package, from within the same package, another class cannot access Z or M3 because they are private. Private means it's only accessible inside the method, the class, sorry, where they are defined. And so even if you are outside the package, okay, well, they're still not going to work. Cannot access Z, cannot access M3. So no one else but the class C1 can actually access Z and M3 because they are private. So if you can use this slide as just a way to review everything, okay, to quiz yourself or to just memorize the rules, this is perfect because everything is summarized pretty much here. So this slide, I already mentioned this twice, so I'm going to go a little fast on it. It's just an example that's pointing out that when you are inside the class where you declare a private attribute or a private method, like for example here, okay, take a look here, public class C, I have a private Boolean X as an attribute and a private method named convert, okay? Well, inside that class, inside any method of that class, including the main, I can use c.x, c.convert. No problem. This is okay. Always okay. Inside the class where you declare the stuff, you can always use the stuff. Now, when you are trying to use class C from another class, another method inside another class, so here I'm creating an object of class C, and then I'm trying to access c.x, c.convert, this is where the private is going to prevent you from being able to access it. Okay, very important that you understand that. Edward, you raised your hand at some point. Did you have a question?
Yeah, kind of the slide we had before. So I've been doing the practice quiz, and it's been kicking my butt. And I'm noticing a lot of the material on the practice quiz is related to that. Is that like, if we fall back on that, if I'm having more problem with the quiz, fall back to this page right here that you're showing, and like a lot of, like if I'm having trouble with a question, check here, and that might help give me a clue. Is that what you're recommending?
This page summarizes everything you have to know about public, private, and default visibility for attributes and methods. So this is a good one to bookmark.
Okay, sounds good.
All right. Question in the chat. So private can be accessed in the same class no matter what? Yes. And if that class is a main method or not? Yes. So let me go back to the next slide here. I'm stuck on this one for a minute. Hold on. There we go. All right. So whether you have a main or not doesn't matter. Okay. Any method, so the main method, a regular method, a constructor method. Okay. Any method found in the class C can access everything that is in that class C. Okay, cool. Well, I'm glad. So that this is why I say, you know, the lecture and the reading assignment are complementary of one another, supplementary of one another, because sometimes I present things differently, and sometimes I'm going to make more sense to you than the book. Sometimes the book is going to make more sense. So it's good that you have two different complementary explanation like that. What about classes? I want to mention that real fast because we're not going to use that a lot in this class, but it's part of what Java allows you to do. Java allows you to also use public, private, and no keyword in front of the name of a class. Okay, so until now we have been talking about attributes and method. So now we're talking about classes. So what does it mean for a class to be public? Well, this is what we have been using until now, and this is what we're going to use for this entire course. That means that you can actually create object, you can access the class. So being able to access the class means being able to create object of that class from anywhere, different package, from within the same file itself or another file, doesn't matter, okay? And again, the public class is what we're going to use almost exclusively in this course. Private classes, these are like really a weird situation. A private class, you can only declare that in Java when you use a feature called inner classes. It's a way to show the class inside another. We are going to cover inner classes in this class. This is in this course. This is a topic more for like an advanced Java elective or something like that. Okay, so we are never going to introduce private classes. And what about the default classes? Well, yes, we are going to have sometime default classes. Default class means that you write something like this. Let me show you real quick in JGraphs. Okay, I have a class here inside the file my data. Okay, let me take this whole class, whole thing here, cut and paste, and I'm going to paste it at the end of my file M1L5 live.java. Okay, so I already have a class here, right? I have a class M1L5 live, and then after the end of the class, we never did that before, but I'm going to paste another class. If I try to do that and compile this, the compiler is going to yell at me, and it's going to tell me pretty much, class my data is public, so the file name should be my data. But no, the file name is M1L5 live because the M1L5 class is public also. So there can be only one public class in a file, but you can have additional classes. Like for example, here I have this class and then I have this MyData class. If I make the choice to give them the default visibility modifier, okay, which means that class MyData is not public, all right? It's default visibility. Therefore, there's only one public class in this file. The name of the file matches the name of the public class. Compiler will be happy. And then it's going to tell me still that there's some things that are not working, but that's unrelated to that. Set data as private access. Yeah, it's because I was messing around and I made set data private at some point. So I'm going to fix that. And now that I fix that, the compiler is going to be a lot happier. Okay? There we go. It compiles, and if I run it, it's still doing the same job. So the default visibility modifier for classes, we're going to use it from time to time. I'll point out your attention to it when we do, but the vast majority of our classes are just going to be one class per file, and so they are going to be all public. All right. So now I need to talk about a keyword that always brings a lot of confusion when you use it in a sentence. It's this keyword. All right. So we have a keyword in Java, THIS, this. And it's kind of like a variable that's always sitting there in the background that's available to you anytime you write the code for a method inside a class. That variable is kind of right there lurking in the background. Let me show you what are the two usages of that variable. Okay, we're going to finish this lecture with this. So first, we use that variable when we want to refer to an attribute of the object on which a method is called. Okay, so that's a mouthful. Let's take a look at some code. Everywhere in the code of the class myData, and we remove this, we are going to go back to our one class per file. Okay, there we go. This is the main, and this is going to be myData. So anywhere in the code for the class myData where I want to reference one of my attributes, I've been writing it like that, data equal v, because that's simpler. But I could, if I want, write it like this. So what does it mean, des.data? It means inside the object, so this is like a reference variable. Des is a reference variable that Java provides you for free, and it always refers to the object on which this method is being called. Like, for example, in the main, when you write d1.getData, okay, d1 is a reference variable. It refers to an object. We're going to execute the code of the method getData, and this will be referencing to the same object. Okay, so you always execute a method on an object. Well, this is just a way to get access to that object with a reference. All right, so it's completely superfluous here because, well, because yeah, I mean, yes, I know that it's data inside my object. I don't need to put des.data, but I can if I want to. And there are times where it's actually mandatory. Let me show you an example. So first, I'm going to compile this to show you that I didn't break it. Okay, so just adding this everywhere didn't change anything. Let's make sure of that. This is a private thing that I didn't correct here. So let me correct this right here. There we go. Build and then run. All right, so it's still running the same way. Well, I did break it, but I broke it on purpose sooner, and I keep forgetting to fix it back. But the des.dot didn't break it. That's the main part that's important, right? So it's still working. It's just that the syntax is a little longer, a little bit more verbose, okay? But there are times where we need it. Let me show you when we need it. If instead of naming that parameter v here, I named it data, okay? The problem is the name of the parameter of one of my methods is the same as the name of one of the attributes inside the class. Okay, that's a problem. And I'm going to show you with the debugger what happens when you do that. Okay, first, when I run it, we are going to have, if I don't use the des.dot notation, when I run it, we should have a little bit of a problem. Let me compile it. I'm going to compile fine as soon as I'm done, like, changing it properly here. There we go. So I'm using the new name of the parameter instead of v is data. Okay. So it's going to compile fine. I swear it's going to compile fine once I stop rushing through it and I actually take the time to read what I write. So like I was saying, it's going to compile fine. There we go. And now we go back to the main. We run it. And this method didn't work. It did not change the value. But it was working a minute ago. And all I did is change v into data. So the problem is now Java doesn't know which data you're talking about. Okay, that's the issue. So it compiles because Java can still make sense of it, but the way it makes sense of it is not really to our advantage. Let me tell you exactly what happens. So when you call this method, it has a parameter named data. So I'm passing here the value 42 in that parameter, okay? So data here is equal to 42. I test if data greater than 0, it's true. So I pass my test. So far, everything is working fine, okay? But this is where things go down the drain. What I mean is I want you to assign data, the parameter, okay, to data attribute. Unfortunately, data as an attribute and data as a parameter, they are spelled exactly the same way. So what Java does, it says, oh, you're talking about data? What did it do here? Why didn't it think it was an attribute? Because Java always says, here's a variable. First question, is it a local variable? Okay, for example, int data equal 999 here. No. If it's not a local variable, is it a parameter? Yes, there we go, I found it. I'm not looking any further, okay? So Java is happy as soon as it finds either that your variable name here corresponds to a local variable in that method or a parameter. In the case of V and in the case of data, the same thing happened. It's a parameter. So when I look here, I say, is it a local variable? No. Is it a parameter? Well, yeah. Yes. So this is the value 42 that I passed. And then what about this one? Same thing. Is it a local variable? No. Is it a parameter? Yes. So I'm pretty much assigning to the data parameter the value of the data parameter, which is awesome. It compiles, it runs, but the problem is that once I assign its own value to the parameter, when I reach the end of the method, the parameter disappears. I never modified my attribute. So in those cases where there is an ambiguity in the naming, okay, you have to use this. You have to say des.data equals data, okay? Obligatory, all right? All right. So if I put des.data here, now it's going to work a lot better. Let's try to give it a run. So what did this now? Set data 42. Let me rebuild it first. I don't think I rebuilt both the files. There we go. Okay. And then let's run it again. There we go. So now that it's rebuilt with the latest version of the code, yeah, the des.data fixed that bug. It's a nasty little bug, okay? No doubt, no question. It's a very nasty little bug. It's silent with respect to the compiler, and then it explodes in your face when you don't expect it. So this is exactly what guide is saying. The des keyword is there to say, by the way, I want to access inside of des object, meaning the object on which you called, you know, for example, the method setI, okay? So if you write a reference variable dot setI, you are calling setI on the object referred to by F2. So this is what this is going to refer to as well, okay? So you want to really be sure to specify this object dot I, the I attribute inside this object. In this example, yeah, we had the same issue. The name of the parameter was, some people say hiding or shadowing the name of the attribute, okay? So you'll see different terminology in different textbooks. The idea is the same, is that you have ambiguity. Java doesn't know which one you're talking about. And then the second use of the des keyword, we're going to finish with this. The last use of the des keyword that we're going to use in this class is when you have des, but not followed by a dot, like we did right now, that allows you to access an attribute, or you could even access a method, okay, inside an object like that. but we follow it with a set of parentheses. And we put, so it's kind of like a function call, like a method call, right? We put parameters in the middle. So that is actually something that you will encounter only inside constructors. So let's go here where we have an example of a constructor. What is the problem that this syntax is supposed to help us solve? Well, I have a constructor here that sets a default value of 999, okay? And I have a constructor here that sets a value that is whatever value you pass to me. So in this case, I would say it's not really worth our trouble to try to do things differently because the code is very easy. But bear with me. Let's say that in order for me to assign the value v, okay, I had to do some computation on v. I had to do maybe 50 lines of computation on v before I can actually assign it. And here, I would have to start with value 999, do 50 lines of computation on 999, and then finally, oops, sorry about that. And then finally, after 50 lines of work, I would go to assign here the result of my computation. Okay, so my point here is that if it's just one line, that's okay. But if it's 51 lines of code here and 51 lines of code here that are identical, that's not okay anymore. So I want to simplify my code here. So what can I do? Well, here I have a constructor that will always do everything that has to be done, no matter what value you want to assign, to figure out what is actually the end result value you want to indeed assign. So it's redundant for me to do those computations twice. What I can say here is I can delegate. I can say inside this constructor, the constructor without parameter, what I'm going to do is I'm going to call that other constructor from the same class that takes one parameter. And I'm going to tell it, I want you to set the parameter 999. So it's the same job being done, okay? This constructor will end up, initializing the attribute data with the value 999, but instead of doing it itself, it just delegates the job to that constructor. So it's really a common occurrence to have constructors that take no parameter, that just make up values on the fly and pass them to the constructors that are supposed to accept multiple parameters, or at least one parameter. Okay, so this is a delegation. This is called constructor chaining, constructor delegation. We are going to talk more about that, but pretty much this is a way for us to simplify our code. I'm going to stop here. We're like over time already once. And two, next lecture, I want to be able to revisit that, make sure I solidify it for you. So I'm going to push back again the deadline for E1. Okay, so IE1, sorry. Stay tuned for that. I want to have time to make one more lecture so that we can finish the slideshow together, and then I'll open the floor for questions, sort of a review before IE1, so that you have time to kind of like let those concepts mature. All right, thank you for putting up with the little bit of overtime here. Once again, thank you for your patience, and we are going to transition now into office hours. So stay tuned if you have questions. I have already 2 chat questions I need to address, so I'll get onto that immediately.